Imagine this. Every second you exist, our planet is spinning at over 1,600 kilometers per hour, circling the sun at a blistering 107,000 kilometers per hour. And you don't feel a thing. But let's zoom out even farther. Our whole solar system is hurtling around the center of the Milky Way at 220 kilometers per second. That's fast enough to circle Earth in less than 3 minutes. Yet, staggeringly, to us, it all feels absolutely still. Stars dot the sky in fixed patterns that seem eternal, but that's only because the distances are beyond our wildest grasp and the clock of the universe ticks at a rate too slow for a human lifetime to notice. Everything, everywhere, is in constant, unstoppable motion. This is the law of the cosmos. Whether it's the electrons swirling around atoms or galaxies tearing themselves apart across millions of light years, nothing rests. This is the story science has told us for generations, cemented into our textbooks with equations that predict celestial motion with eerie precision. But what happens when cosmic choreography gets interrupted? When something refuses to move the way it's supposed to? A few years back, we got our first taste of what it means to spot a true interstellar visitor. Oumuamua, a name that translates as messenger from afar, tumbled into our solar system in 2017. It looked strange, behaved oddly. People argued for weeks whether it was a comet or an asteroid. But its movement was, for the most part, nothing extraterrestrial in logic. It came in fast, sped around the sun, and shot back into the dark. The math added up. The next big act was Tuipursov, an undeniably alien comet loaded with ices, showing off a classic tail and following a path that only something from another star could. Again, the physics smiled. It arrived, whizzed by, and left, just as the laws of motion predicted. These interstellar wanderers move fast, because escaping their home stars takes an absurd amount of kinetic energy. Once they break free, space offers almost nothing to slow them. Literally. Interstellar space is so empty, you could count the average particles per cubic centimeter on one hand. Picture a ping pong ball set loose in a football stadium after everyone left. That's how little resistance anyone expects. Then, in an otherwise uneventful night, in January of 2025, a new blip was caught by the massive digital eye of an asteroid survey. This was 3I Atlas, and at first nothing seemed out of place. Atlas was big, bigger than its predecessors, sturdier too. Not a whisper of a tail, no sparkling jets of gas, no tumble under the sun's harsh glare. Its trajectory was right in line for an object ejected from somewhere unimaginably far away, cruising at about 43 kilometers per second. Seriously, at that speed, it could cross the diameter of Earth in 8 minutes. And if you were tracking its course, you'd see the familiar pattern, inbound and gaining speed as the sun's gravity lent a hand, then curving back out to the interstellar wild, just as the law of Newton demands. At least that's how it looked, until it didn't. Astronomers began picking up something unnerving. The numbers on their screens started to slip out of line. Atlas was slowing down. Not by much at first, maybe 4 kilometers per second, then a few more, then a few more. Every measurement, every fresh line of data seemed to agree. If there were cosmic speed traps, Atlas was hitting every single one. This should be impossible. In a place where an object can coast unimpeded for millions of years, 3I Atlas was behaving like it had hit an invisible wall, or like someone was gently applying the brakes. Think about tossing a stone across a frozen, frictionless pond. Physics says it should glide forever. That's space. Now imagine watching that stone start to slow for reasons you can't see or feel. It's a violation baked into the bedrock of everything we know. Here's what's even creepier. Atlas wasn't spinning to create strange drag. It showed no ejections of gas that could act as a tiny thruster. There was no sudden brightness, no hint it was breaking up, spewing debris, or colliding with anything. Instead, the data revealed an immaculate traveler, stable and serene, somehow bleeding away its velocity on a course that should be immune to friction or force. If nothing in the vacuum of space can slow down a cosmic wanderer, why was this object disobeying the bedrock rule of the universe? Was it caught by some unseen hand? Or was it acting of its own accord? That unresolved question gnawed at every scientist's mind, raising stakes far beyond celestial mechanics. Because if one lonely object can break the oldest law in the book, then maybe, just maybe, our entire view of the universe is about to change. But if you think that's unsettling, wait until you see what happens next when scientists try and fail to explain the inexplicable. Now imagine you're in the control room of an observatory, bathed in the bluish glow of endless monitors, listening to the quiet hum of machinery as the universe sends its messages one photon at a time. You notice those strange readings from 3i Atlas. Your first instinct is denial. Maybe it's a glitch, maybe a round-off error, maybe just the universe mocking you for staying up too late. But the numbers won't stop, and soon, observatories across the world confirm what you're seeing. Atlas, legendary interstellar visitor, is slowing down, not veering off course, not flickering like it's breaking up, just dropping speed as steadily as a car rolling down an invisible ramp. Every scientist worth their salt wakes up fast, because what you're seeing is the equivalent of checking every circuit breaker after a blackout, only to discover none are blown, the lights just refuse to come on. It sends chills through your bones. The universal constants are wobbling. First up, the obvious suspects. Outgassing is a trick comets pull. Solar heat cooks up buried ice, it bursts out in jets, giving the comet a tiny push and sending a tail streaming behind. It's celestial rocket science, literally. But for Atlas, not a hint. No tail, no coma, nothing boiling off. Even under the forensic gaze of the best telescopes. Scratch that off. An impact with another space rock? You'd expect to see debris, a spray of fragments, fresh scars glinting in the sun. Yet Atlas is as pristine as a trophy ship in a glass case. No shrapnel, no flash. Next, they run the math on something exotic, the Yarkovsky effect. It's how some asteroids drift. They heat unevenly in sunlight, re-radiate infrared energy, and a teensy force nudges them, millimeter by millimeter, across eons. Too subtle. To slow a boulder like Atlas at these speeds, you'd need Yarkovsky forces cranked up to fantasy fiction. The numbers just laugh you straight out of the room. Magnetic fields? Only work if an object is both electrically charged and moving through a wildly strong field. Atlas checks neither box, and even if it did, the effect would be so weak you'd need 1,000,000 centuries to see a difference. Solar wind? Like being battered by a gentle cosmic breeze. But for something this size, that breeze is a joke. Picture sending a battleship across the Pacific and hoping it gets delayed by dragonflies. Still not convinced? Teams start to worry about their own eyesight. What if all these fancy instruments are feeding back a hallucination, a phantom created by some software bug or calibration goof? But now, there are too many telescopes in too many nations, staffed by too many seasoned scientists, getting the same impossible result. They're running cross-checks faster than a caffeine-fueled chess player. Everything else in the sky behaves as expected, just not this one object. It gets more haunting as the days pass. Each night they watch the speedometer drop. 39 kilometers per second, then 35, then 31. Imagine watching a sprinter on TV blowing by the competition, and then, without changing stride, tripping or suffering a cramp, slowing to a jog in an empty stadium. Nothing in the rules of the race says that's possible. But here, in the real, cold, endless void, that's exactly what's happening. It's not just scientists peering at their graphs who feel the shiver. Anyone who's ever thrown a ball, ridden a bike, or skidded a stone down a frozen pond lives by Newton's first law. Objects in motion stay in motion, unless stopped by a force. That force is always something real. On Earth, it's friction, air resistance, gravity. In space, it's gravity, or nothing. But here, faced with the largest, emptiest nothing of all, something invisible is exerting just enough pressure to admit its presence, but never enough for us to call it by name. In coffee rooms and lecture halls lit by the bleak light of cosmic uncertainty, astronomers begin to murmur, what would it actually take to slow down an interstellar slab this size? The answer is disturbing, because nothing short of a deliberate intervention or a yet unknown force fits the bill. The cosmic suspects are all innocent or missing from the lineup, but the pressure is rising. If the universe isn't playing by its own rules, what rulebook is it using? Or, and here's where it gets truly unsettling, what if Atlas isn't being slowed at all, but slowing itself? Could this be a case of cosmic agency, a clue that the universe is far less mechanical, far more mysterious than we ever believed? What happens next forces science to trade its comforting facts for lingering questions. Because as the hunt for natural explanations comes up empty, minds are driven to consider something far more monumental. A force, a presence, or perhaps a purpose for which our understanding has no precedent. If we thought the math was scary, the next step is even scarier. Searching for invisible hands in the dark and realizing they may just be waiting to reveal themselves. Step into the shadowy realm of the almost plausible, where the universe hides its deepest tricks, not just in what we see, but in forces that barely whisper across the dark. When every physical explanation collapses, astronomers do what they do best: hunt for the invisible by what it moves. Think of Neptune, a planet found not by the twinkle of its light, but by a ghostly tug it exerted on Uranus. Back in the 1800s, a mathematician scribbled down numbers that pointed telescopes toward an unseen giant. Proof that sometimes what you can't see can still be found, if you're willing to chase wrinkles and wobbles in what's visible. So, hope kindles. Maybe 3i Atlas is being slowed by something just out of reach. A mass hiding in plain sight. The dark matter scenario rises first. The universe is stitched together with this mysterious substance, outweighing ordinary matter 5 to 1, yet refusing to show up in any photograph. Most of the time, dark matter is thought to be smeared in vast halos around galaxies. But maybe, just maybe, space is peppered with denser clumps, rare and unnoticed, until an unlucky traveler plows straight into one. The math says, possible, but not likely. To break Atlas as hard as we see, this clump would need to be not just unusual, but freakishly, record-breakingly dense and local, something astronomers have never seen, despite shaking down every dataset for decades. Plus, if there were a clump lurking nearby, it should be yanking at anything else passing through. Comets at the edge of the solar system, icy debris, even the paths of far-off probes. But quietly, nothing else flinches. It's like setting the world's strongest tripwire for one single passing object and watching every other traveler skate over it unscathed. Next up, the primordial black hole conjecture. These hypothetical relics from the baby universe are invisible, smaller than a city but heavier than a mountain. Their gravity could, in theory, trip up a speeding asteroid, slowing it down. But if Atlas skirted so close to such a cosmic landmine, Not only would its path warp dramatically, but its speed changes would spike and dip in a pattern as unmistakable as a thrill ride at an amusement park. Instead, the slowdown is steady, gentle, and persistent. No spiky gravitational fingerprint. Plus, the odds of a black hole just happening to align with Atlas's path, out of all the frozen emptiness of interstellar space, are so small you'd make a better bet picking a specific snowflake out of all those that have ever fallen to Earth. Rogue planets and brown dwarfs, wandering worlds jettisoned from their star systems, join the parade of suspects, massive enough they could tug on interstellar visitors, twisting trajectories and draining speed if they pass close enough. Yet, we've combed the nearby sky with infrared telescopes, fine-tuned to pick up even the faintest warm glow of planets adrift. Nothing matches up. Space, as always, appears emptier than a long-forgotten attic, free of lurking giants we could credibly blame. This is the cosmic lottery. The odds of an object like Atlas happening upon just the right patch of gravity, perfectly placed and perfectly timed, are almost zero. It would mean the universe is stacked with invisible causes poised to act not on millions of candidates, but on just the one we've managed to spot. Yet the uncanny precision of the slowdown, steady and isolated, makes such a coordinated chance almost impossible to swallow. You might feel a chill like you do when you realize every shadow is just a trick of the light, until the light itself begins to behave strangely. If space isn't hiding massive objects in the classic sense, and nothing else in the solar system is being pulled off track, then the explanation must reach even deeper, right down to the heart of how we believe the universe works. This is the tipping point where imagination makes its move. What if, the scientists nervously whisper, we're watching an object slow down, not because of an accident or a shadow or a gravitational trap, but because that's exactly what it was always meant to do? What if the weirdest answer, the one we resist most, is the only one left standing, that perhaps the universe just showed us the tip of an intentional act? Maybe Atlas's slowdown isn't a cosmic accident at all, but a message disguised as an unthinkable maneuver. A new possibility glows at the margins. The object is slowing down on purpose. And now, the question isn't what's hiding in the dark, but who or what decided to press the brakes and why. Get ready. For the next revelation is so audacious, so paradigm bending, that you might never look at a flying rock or the cosmic silence above us the same way again. Pause for just a moment and picture this. The most advanced spacecraft humanity has ever built, Voyager 1 New Horizons, slipping through the void with their fates sealed in math. Every movement planned, every thruster pulse deliberate. When they adjust course, you see it in the telemetry. A crisp, unmistakable blip. These maneuvers aren't like the chaos of an asteroid or the meandering of a comet. They're precision art, a signature of control, purpose, and intelligence. Now, apply that same logic to 3I Atlas and its slow, measured deceleration. Nothing in nature, nothing random, slows with such elegant consistency, at least nothing we've ever cataloged in the endless inventory of the night sky. As scientists stared down the growing mountain of data, one realization came creeping in, unwelcome but impossible to ignore. This wasn't chaos. It looked suspiciously, almost hauntingly, like intent. What if you wanted to announce yourself to an emerging civilization? One tuned, finally, to subtle anomalies, not just flashing lights. Would you really scrawl hello across the atmosphere, or would you do something only a keen observer would notice? Break a universal rule, gently enough to puzzle rather than terrify? There's a sly genius in subtlety. It's as if Atlas is whispering its presence, not shouting. For decades, we've dreamed about the day aliens might call us, waiting for radio signals out of the cold dark. But what if the actual first message, a deliberate handshake, was encoded in an act that violates the bedrock of physics? No language required, no antenna or telescope could truly miss it. Here is something that shouldn't happen. Take a closer look at how Atlas performs its impossible feat. The deceleration is not a stutter or random lurch, but a smooth, constant thrust, if you can call it that, subtle enough to ride the edge of our detection, but precise enough to trigger sleepless nights in the world's best labs. No surges, no spins. It behaves less like a rock and more like the first controlled descent of a surveying drone. It's as if a hidden pilot calculated just how much to slow down, enough to make us look twice and wonder. The more astronomers examine the data, the less it resembles chaos and the more it looks like choreography. And then there's the choreography's uncanny timing. Atlas maintained typical interstellar speed for thousands, or possibly millions of years. Its path only diverged from the expectations once it was close enough to our array of digital eyes. It's like a performer waiting for the curtain to rise before stepping into the spotlight, every cue meticulously prepared. Imagine you're planning a secret arrival in a city. You don't storm in, you pause on the edge, taking stock, watching reactions before making any bold moves. Is Atlas following a similar protocol, observing before interacting, gathering data before revealing more? The silence, no radio chirps, no blinding light, could itself speak volumes. The visitor may not just be sneaking through, it could be studying, evaluating, learning. It's easy, even comforting, to dismiss all this as pure coincidence. But history and myth suggest otherwise. Cultures have stories of stars that guided travelers, like the Star of Bethlehem, said to move in the sky and then stop, or the tales from ancient China and the Americas about wanderers among the stars behaving with purpose. For generations, we called such events miracles or legends, chalking them up to the overactive imagination of skywatchers with nothing but firelight and parchment. But maybe, just maybe, some of these accounts echo real encounters, glimpsed through the lens of ancient understanding. Could it be that the pattern, a moving light that pauses, that lingers just long enough to draw attention before moving on, is as old as civilization itself? And if Atlas is just the latest emissary in a long line of enigmatic visitors, what could it be waiting for? What test is it setting before us? Are we meant to notice, to ask, to reach back in our own way? Is this careful ambiguity a kind of cosmic filter, a test of patience and perception, intelligence and imagination? Or is it a demonstration, a soft warning, a promise that the universe is not just an arena of rocks and gas, but a place where intention and agency might dart through the dark like a message in a bottle? If Atlas is a messenger, not a mindless stone, its silence is an answer and an invitation both, daring us to dig deeper, to question what we think we know. So the next startling question isn't whether something is out there, it's whether we'll even recognize true contact when it comes dressed, not as a transmission, but as a puzzle, the riddle of an object that refuses to play by the rules. And as you ponder this, keep your eyes on the sky, because the next act in this cosmic drama could shatter everything we thought the universe was willing to reveal. So, the universe has tossed its wildest curveball, an interstellar visitor that breaks where nothing should. If you're not sitting up a little straighter right now, think about what's at stake, the very way we define the cosmos and our place within it. For centuries, we've found comfort in the ironclad predictability of physics. The rules, constant, unbreakable, and above all, universal. They told you where a planet should wander, when a comet would return, how fast a spaceship needs to travel to break Earth's grasp. Our progress, every moon landing, Every probe sent across the void has ridden on this trust. But 3I Atlas's deceleration asks a forbidden question. What if the universe doesn't always play fair? The ramifications are staggering. If Atlas is operating under principles unknown, it might be a herald of new physics, inviting us to tear up old equations just as Einstein did when Mercury's orbit didn't fit Newton's scheme, or as Planck and Einstein did with the first hints of quantum weirdness. It wouldn't be the first time a celestial object forced us to expand the bounds of scientific law. Historically, every anomaly has been a secret door to a more profound truth. Imagine for a moment what could change. Maybe there's a force or interaction out there, a new wind in space, that only reveals itself under rare, precise conditions. Maybe Atlas is a clue that reality offers more variables than we've dreamed. But let's lean even deeper into the uncomfortable. What if physics, as perfectly as it describes falling apples and spinning galaxies, wasn't actually violated at all? What if the anomaly is telling us that something out there is making choices? A traveler with motivations, technology, and patience so advanced that its first act is to blend into nature until the perfect moment arrives. The sense of possibility is as exhilarating as it is terrifying. The next phase of humanity's cosmic story may not be about discovering new atoms or new laws, but about meeting something or someone who can use the rules of motion as a canvas. We crave signals, alien radio pings, mysterious transmissions. But perhaps the most sophisticated message is demonstration, not conversation. If that's true, what then? The classic question, are we alone, mutates into something bigger, more haunting. Will we know it when we aren't? What if, as you look up at the sky tonight, the answer is unfolding right in front of you? A slow, patient dance, not of light or static, but of impossible behavior. How does it feel to live in the moment when the universe itself stops being a locked box and becomes a mirror, hinting at agency beyond our own? It might be humbling, even scary, but it also could be the greatest invitation we've ever received. Now, every time you stand beneath the open sky, you're no longer just an observer, but a participant in the most ancient of human pursuits, watching, wondering, waiting for the next sign. Whether Atlas is a messenger, a pioneer, or a mute witness to laws beyond our grasp, its presence transforms us all into sky watchers, ready for anything, aware that the next anomaly could be the universe waving back. Imagine the next Atlas lingering in the heavens, a sign not just that we are being watched, but that the universe is so much stranger, deeper, and more filled with possibility than our narrow moment in history could ever predict. Will the night sky feel emptier or more alive? Once you accept that the rules can be rewritten, that perhaps, somewhere above, another intelligence waits for us to notice. The next time you look up, ask yourself, is it just stars and silence? Or could you be witnessing the slow choreography of something or someone testing the waters of contact, playing a cosmic game of patience and nerve? Because if one mysterious visitor can change momentum by choice, what else might be choosing to cross our path? And when will we be ready to respond? Maybe that's the true message Atlas brings. Not final answers, but the sudden, dazzling realization that the universe still holds secrets we've barely begun to imagine, and that the story of who is watching whom isn't finished at all.